Good evening, everyone. My name is Michella Maddox-McGhee. I work closely with Dr. Khan, this project focuses on predictive modeling of angular insertion depth and lateral wall cochlear implant electrodes. So, just one minute. I'll briefly cover background, the problem, methodology, results, and finish with ethics and future work. So let me just, before I move forward, I just want to go over some quick definitions. Base, base insertion depth is how far the electrode is inserted in the inner ear. The angular insertion depth is how far it wraps around the cochlea. And the cochlear scale represents the size of the cochlea. These are the key variables that were used in the study. So cochlear implants restore hearing by stimulating the auditory nerve using an electrode array. However, outcomes depend very heavily on how the electrode is positioned in the ear. So if you see in this picture, this is the electrode array in the cochlea. So for better visibility, I have a animated picture and a demonstration. So the cochlea is a spiral structure, and electrodes are inserted in the scala tympani. That's this space right here, the light blue. Because of its shape and limited visibility, precise placement is challenging. As you can see on the right, the student is trying to practice inserting the electrode array. It's very challenging. Oh, sorry about that. All right, so if the electrode is inserted too deeply in the ear, it can damage the regions that are responsible for residual hearing, meaning hearing that still works for the patient. So surgeons must balance deeper insertion with preserving the existing hearing. And that's why over insertion is a problem. We have that's the problem we're trying to address. So here are the obstacles, and the main aim of this study is to predict angular insertion depth before surgery. This helps guide electrode selection and improve surgical precision, despite anatomical variation, meaning the anatomy of the cochlea from person to person. So the data set consisted of CT scans from 86 patients, all with lateral wall electrode arrays of different types, 5 different types. This provides consistency, but it limits general 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 it limits it being general. So it's tailored to the person. So CC's images in the previous work, this is not mine, but this is previous work, were processed to extract cochlear anatomy and electrode positioning. And using these features, both geometric and machine learning models in the previous work were developed to predict angular insertion depth. These approaches were then compared. And so looking at these correlation, it shows the correlation between the key variables. From the table, the base insertion depth shows a positive, strong correlation with angular insertion depth, meaning that as insertion depth increases, angular insertion depth also increases. Other variables like cochlear scale and electrode geometry show moderate or not as strong correlation. And so there's also partial correlation, which measures the relationship between two variables while controlling for others. And there is a positive correlation, strong correlation along the electrode array length. So I'm going to move forward, sorry. And the BID, sorry about that. So this slide focuses specifically on base insertion depth and angular insertion depth. And before controlling for other variables, the relationship seems very strong. You can see right here in the picture that it's a strong correlation. This line represents the perfect, insertion depth. So on the right, it measures the residual, meaning the patient's hearing that they have left. Sorry. And this confirms, from this visualization, it confirms that base insertion depth is one of the most important predictors. Metric models, that was previous work. It relied on predefined formulas, while the data-driven models learn patterns from the data, and it produced lower prediction errors, as you can see in the box plot in the box, the chart. So these box plots compare prediction errors across different feature combinations. As more relevant features were added, the prediction error decreased, and this shows that combining anatomical and electrode-related variables improved accuracy. So in the previous work, linear regression, it did perform reasonably well. However, the SVM model achieved lower error and variability. It had a better MAE score. It scored lower, 27 degrees. So in my work, I actually used a total of 6 machine learning models that were tested along the way to get the best MAE. SVM is the model that actually achieved the best overall MAE, which means mean absolute error. And the 6 machine learning models were XGBoost, which means extreme gradient boosting, AdaBoost, adaptive boosting, that's what it means, random forest, gradient boosting, which one, like I said, and then KNN, which is K nearest neighbor. So some considerations, ethical considerations, the prediction error should be used cautiously. There should be a limited small data sets, even though that does present some bias, being a small data set, but that is one of the problems with using small data sets, but it is more ethical by using small data sets. And then this research actually supports and not replace surgical judgment. So it should, all research should just support, not replace it. So for some future work, I would love to expand the data set to include more cochlear anatomies and implant types, if there are any implant types out there. Want to validate model performance in clinical settings with surgeons. And then I would love to extend the model to predict hearing outcomes, not just insertion depth. I want to know what happens after these so after the surgery, how well the hearing of the patient becomes. And I just want to acknowledge that this work was supported in part by SACS, Dr. Khan, and Meharry Medical College. Thank you for your time, and I'm happy to take any questions.
So it's not a question, it's a comment that this work has a lot of potential to extend, and it's a good thing that you worked with a real data set. And yeah, the floor is open for the questions because we have